Hello guys, today's topic is Numpy Statistical Functions. This is session 8 of Numpy. In this session we are going to talk about Numpy Amin Amax. Numpy has a quite a few useful statistical functions for finding minimum, maximum, percentile, standard, deviation and variance. From the given elements in the array, we'll discuss about those functions. Numpy Amin Amax. These functions returns the minimum and the maximum from the elements in the given array along the specified axis. Let's check out the example. I'll open the NumPy static function. Right, first we'll import the NumPy as np and I'll define the array np dot array, and in the array I'll assign the numbers. I'll take 3, 7 and 5, and the next one is 8, 4, 3, and the next one is 2, 4, 9. Right, now I'll print our array is. Next print of a, and I'll print a line break. Import the, not the import numpy. Right, this is our array. It's a array which we have defined. Now we'll try to apply a min a max function. Print applying a min function. Now we'll apply a min function. np dot a min. You can hit the tab key to see all the functions available there. Yeah, you have seen a min there, right? A min of a, comma 1. Next, print, will apply line break and see what we have the result. So 3, minimum is 3 and 3, and here it is 2, right? And I'll apply the one more a min function, and I'll take this a comma 0, right? I'll execute this and let's check what do we have here. We have 2, 4 and 3. 2, 4 and 3, right? Right. And I'll try one more a min. Instead of 0, I'll remove that and just I'll enter the a. Now, in first we used 1, a comma 1, so we have in one row, and 0, so we have the answer this. And for the a, let's see what we'll have. We'll have the minimum value from this ad, and we have the minimum value is 2, right? Now we'll try to find the value of a max. We'll find the value of a max without the axis. So instead of a max, let's see what we have here is a max is 9, maximum number is 9 here, right? So we'll find the same value with axis of 0. Axis of 0. What do we have here? 8, 7, 9. We have the minimum value of 8, 8, maximum 7, 9, 8, 7, 9. So we are talking about axis of 0. So we have the result as 8, 7, 9. For the axis minimum of axis of 0, what we have? Minimum of axis of 0. So we have 2, 2, 4, 3. Now maximum of axis 0, what we have? 8, 7, 9. So we have 8, 7, and 9. So axis 0 is this, axis 1 is this way, right? So 2, 4, 3. So the least is 2 here, and least 7, 4, 4 is 4, and 5, 3, 9 is 3. So 0 axis. So for one, axis 1 is 3, 3, and 2. Is it clear? Alright, we'll move on. Next topic, NumPy PTP. The NumPy PTP function returns the range maximum minimum of values along an axis. So it returns maximum and minimum of values along an axis. Whichever axis you are looking for, it will display it. Let's check it out. NumPy.pdp. First we'll import NumPy as NP. So what I do is I'll take the value. Okay, if you want to minimize this output session, just double click there. It will be minimized. Okay, so I'll take the same values here. This one. Okay. Now we will apply PTP function. Print applying PTP function. Next, print np.ptp of what a, and we'll have a line breaker, and let's check this out. So what do we have? PTP, we applied PTP for a, we have the answer 7. So why? We haven't provided any axis, so it's taken the first index. Right, now we'll apply the PTP on axis 1. Now I'll copy this function on axis 1, right? So it's simple, just you need to enter comma here and axis is equal to 1. Simple as that. So what do we have here for axis 1 is we have 4, 5, 7. Right, now we'll try for the axis 0. Try for axis 0. So here we'll change it to 0 and let's see what will be the results. So axis 0 we have 6, 3, 6. Right, right. Let's move on to the next one, percentile. The percentile, or it can be called as a centile, centile, right, is a measure used in statistics indicating the value below which a given percentage of observations in a group of observations fall. The function numpy dot percentile argument works as a number. I'll type it here so that you can note it down. The argument numpy dot percentile a comma q comma axis. So what is a, what is q, and what is axis? A is a input array. Q, the percentile to compute must be between 0 and 100. Right, the axis along which the percentile is to be calculated. Let's check out this example. So here numpy dot percentile. Let's import numpy as np, and a is equal to np dot array 30. I'll take 30 comma 40 comma take 70, and the next I'll take 80 comma 20 comma 10, and the next third array 50 comma 90 comma 60. Right, now let's print our array is our original array, and print a print of colon slash n. Let's print out this is our array. Now applying percentile, function. Let's try this. Applying percentile function. Print np dot pe. This press tab, you have it there. Percentile of a comma a value. We have discussed about that. A comma q, right? What is q? The percentile to compute must be between 0 and 100, right? So I'm assigning as a 50. Now print will have a line break. This is the results. So applying percentile function to a. So what is the percentile function? Is 50. Is it clear? Now we'll apply the percentile function along with axis 1 function along with axis 1. For that we need to change it, comma, here axis is equal to 1. Now what we have the result? Let's see. So applying percentile function along with axis 1 on 50%. So we have 40, 20, 80. We have 40, 20 and 60, right? Now we'll apply the percentile function with axis 0. So axis 0, so we have it 50 and 40 and 60. So check it out. 30, 80, 50 in axis 0. So it's shown 50. In 90, 20, 40, it's shown 40. In 70, 10, 60, it has shown 60. Right. Let's move on to next one, next topic. Median. Median is defined as a value separating the higher half of a data sample from the lower half. Now let's check how the Numpy median function is used, and we'll try in the code. Alright, let's import Numpy as np, then array. We define an array np dot array, and take is 30, 65, comma 70. Next we take it as 80, 95, comma we take 10, and the next one we take 50, comma 90, comma 60. Right. Now print our array is next print of a, next print of colon n. So it will print our normal array. Now we'll try to apply the median, right? Print, applying median function, print np dot median of a, and we'll type a line break. So median of a is 65.0. So starting from 30 ending till 90, the median is 65. Now we'll apply the median function along with axis 0. Median function along with axis 0. So what we have to do it here is a comma axis is equal to 0. Simple as that. Here now you can see that for axis 0, what we have a median. Median is the middle value. So we have 50, we have 90, we have 60 again. Let's try the same thing for axis 1. So applying median function along with axis 1, we have it here 65, 80, and 10. This is 65, 80, and 60. Right? Is it clear? So this is median. And now the mean, numpy mean. Arithmetic means is the sum of elements along an axis divided by the number of elements. The numpy.mean function returns the arithmetic mean of elements in the array. If the axis is mentioned, it is calculated along it. Right. Let's check this out with an example. Alright, let's array 1, 2, 3, 3, 4, 5, 4, 5, 6. Now print our array is print of a, print of slash n. Let's see how. Or this is our array 1, 2, 3, 3, 4, 5, 4, 5, 6. Now what we do is print. Now we'll try to apply mean function. Print of np dot mean of a, print colon n. So mean function of this is 3.66. So we have the maximum was 6 and the minimum was 1. So it has calculated as 3.66666665, right? Now let's try this with axis 0, then axis 1. We'll see function, applying mean function along with axis 0. So what do we got to do it here? Comma axis equal to 0. Now let's see what is the result. So for axis 0, we have 2.6, 3.6, 4.6. Same thing will apply for axis 1 as well. Let's see what will be the result. So we're going to change it here, 1, and hit shift enter. Now we have axis 1, 2, 4, 5. This is 2, 4, and 5. Right. Is it clear? As simple as that. Okay, let's move on to next topic, numpy.average. The average is an average resulting from the multiplication of each component by a factor. The average function computes the weighted average of elements in an array according to their respective weight given in another way. The function can have an axis parameter if the axis is not specified. The array flatten considered as array, and the corresponding weights. For example, if the array is 1, 2, 3, 4 and corresponding weights is 4, 3, 2, 1, the weighted average is calculated by the adding the product of the corresponding elements and dividing the sum by the sum of weights. Like, let's consider this as this is our array 1 comma 2 comma 3 comma 4. Let's consider this, and corresponding weight will is this is our corresponding weight. Just imagine to understand this average scenario and how weighted average will work. And write A W A. In this way, how it's gonna work is 1 into 4 plus 2 into 3 plus 3 into 2 plus 4 into 1, right? And here divide by 4 plus 3 plus 2 plus 1. It works in this way. Right. Now let's check this out with an example. Numpy average. First we'll import numpy as np. A is equal to np dot array. Our array will be 1 comma 2 comma 3 comma 4, right? And we'll print our array is print of a. This is all. It will print our array. Print. It will give the line break. Let's execute this and see our array. So we have it. This is our array. Now applying average function. Print. So print. Now we'll apply the average function np average of a. Now print line break, and let's see what we have. Average is 2.5. Applying average function is 2.5. Right? This is same as the mean value. Weight is not specified. right? Average. When weight is not specified. Now, let's move on to here. WTS is equal to NP dot array. Now I'm specifying the weight, right? Now, print applying average function again with weights. Print NP dot, excuse me, empty dot average of A dot weights is equal to WTS. This is WTS is our weight, right? Print of line break. Let's execute this and see what we have. We have an error here. Keyword cannot be expressed. Why? I have entered here dot. It should not be a dot. It should be a comma. Right now we have the answer there. What we have applying average function again is 2.0. So the average function applied with weight, right? Before the average function was 2.5. Now we have it 2.0 with weights. Now we'll try to print out the sum of weights. Try to print out the returns the sum of weights. Sum of weights if the return is set to true. Print sum of weights. Now print np dot average of 1 comma 2 comma 3 comma 4 comma weights is equal to 4 comma 3 comma 2 comma 1 and comma return is equal to true. Let's see. So we have the answer here. We have sum of weights is equal to 2.0 and 10.0 based on the calculation. Right. So we have the standard deviation. Make it quick. Standard deviation is the square root of the average of square deviation from mean. The standard deviation is if the array is 1, 2, 3, 4, then it means is 2.5. Just we have checked it. Hence, the deviation it calculates in a different way, and the square root of its means divided by 4. Let's check this out in our example. Standard deviation. Let's save this. Okay, let's import numpy as np, then print np.std. Std is nothing but a standard deviation. 1 comma 2 comma 3 comma 4. Enter. So we have this, the answer. Right. So hope this understood the complete scenarios of the statistical functions what we have learned today. So if you have any doubts, feel free to contact me. This is a very simple and easy way to practice, and the more you practice, the more you learn. Right. All right, guys. You take care. Look after yourself. I'll join you next session. Bye bye.